All right, let's get started. So good morning, good afternoon, everyone. Welcome to Avi Networks Takeoff Tuesdays webinar. Today's topic is automated self-service load balancing and monitoring with Cisco and Avi. My name is Ashish Shah, and here with me is Ranga Rao, our guest from Cisco. Welcome, Ranga.
Hey, Ashish. Thanks for having me over.
Thank you for joining. So we have a great webinar in front of us. As we get started, here's some logistics. Please ask questions on the Q&A panel on the GoToWebinar. We will address these questions at the end. This webinar is being recorded, and recording will be available later this week. So what to expect in the webinar today? Well, we'll spend about 15-20 minutes on the presentation, and then we'll go directly into the demo. Okay, so let's make sure. All right, we're ready to go. So first of all, let's address application deployment challenges today. Today, when you have to deploy any application, a 3-tier app, you have to manually install most of its components. At best, you have automation with scripts for web servers, application, and databases. However, to deploy network connectivity as well as the network services such as firewall and load balancer, you have to open tickets. That's painful. In addition, you have to deploy separate tools for monitoring, analytics, log searches, end user insights, and so on. And each of this results in its own set of tickets. Well, what if we could simplify this process, automate it in a policy-driven fashion? That's what Cisco and Avi have done together. We have brought simplicity and automation into application deployment. With the joint solution that you'll see today, what we've done is a single-click deployment of the joint solution, automated application provisioning that's that's policy-driven, and finally, full visibility into network layer all the way to the application layer. Finally, we've also integrated monitoring and analytics tools to bring you that in a single unified solution. What this drives is the business benefits, which is you can deploy your applications much faster, reduce operational complexity, which reduces operational cost, and then that results into a business agility for your environment. So with that setting, let me hand over to Ranga. Ranga, can you describe how Cisco is solving the application deployment challenges at the network layer and also at the service insertion layer as part of this joint solution?
Sure, Ashish. As you know, networks have traditionally been a collection of boxes, deployed and managed as a collection of boxes. So network admins typically log into each and every box in racks and the rows and essentially configure these with very network-centric terms like VLANs, subnets, policy-based routing, and so on. With Cisco's application-centric infrastructure, which is Cisco's next-generation SDN technology, what we have tried to do is move away from this box-by-box model and come up with a model of actually building a fabric and managing the entire fabric as one entity. So Cisco's ACI, or application-centric infrastructure, has been designed to work as one entity managed by the controller, which is the Application Policy Infrastructure Controller, or APIC for short. And as part of the demo today, we'll see some of the screens from APIC. So in this model, customers can bring their workloads, be it physical or virtual, and have a policy-based connectivity provided to that particular workload. What do I mean by policy-based connectivity? What I mean is a configuration model for the connectivity for the workloads, which is very application centric and not very infrastructure centric. So the users do not have to really deal with terms like policy based routing, QoS, and so on, all the network centric terms. In fact, they can just configure the infrastructure in the language of the application. So in this example that I'm showing over here, we have a 3-tier application with a web, app, and database tier with policies that say that only the web tier is accessible from the outside world, but you need to go through a filtering or a QoS based policy. Between the web and app tier, you need to go through layer 4 to 7 services and also filter the traffic. And between the app and DB, you have similar rules. So the ACI infrastructure can take these application-centric policies and actually automate the configuration of the entire infrastructure for that particular application. And one key aspect of this automation is how we automate insertion of layer 4 to 7 services, which is why we are in this room together and in this webinar to discuss how we can essentially automate the end-to-end application provisioning. So with ACI provides a framework for layer 4 to 7 service insertion, where you can dictate that between any two tiers. In the previous example, I had a service chain between the app and the web and the app tier. You could essentially say that I need to have a chain of services which are first a firewall and then a load balancer, or any kind of services that customers would like to insert between these tiers, and those services will be automatically inserted. And what I mean by that is that the network will be instructed to force the traffic through those services, and return traffic will be handled. And in conjunction with layer 4 to 7 service node managers like the Avi manager will essentially be able to automate even the configuration of those layer 4 to 7 service devices. Let's take a closer example. We have, like we were talking about, we have the web tier and the app tier. In the ACI world, these tiers are modeled by what we call as an EPG, or an endpoint group. So in this particular slide, we have a web EPG to the left and an app EPG to the right. And the policies that control how traffic flows between these two endpoint groups is modeled by what we call as a contract. So we have a contract over here. And this contract has been designed to allow some traffic and to maintain some accounting of the traffic. And the key part is that it actually instructs that there should be a service graph that should be inserted between the web and the app tier. So the model actually provides us for a lot of flexibility to determine what traffic should we allow, and when we allow the traffic, what kind of policies should be deployed. So here we are essentially going to insert a layer 4 to 7 service graph with services that's managed by Avi. So Ashish, maybe this is a good time for you to share some information about what Avi Networks does and how we have an integration between the Cisco ACI infrastructure and Avi Networks technology.
Absolutely. Thank you, Ranga. Thanks for the introduction and overview of Cisco ACI. I'll spend a couple of minutes on what Avi is and then talk about the joint solution. So Avi is a Silicon Valley network software company. It's about 3 years old. However, we've been shipping software since middle of last year, and we have multiple Fortune 500 customers. What does Avi do? Well, for those who don't know, Avi has built an elastic application delivery solution, which means elastic load balancing, application security with SSL offload in 100% software form factor, combined with integrated analytics, which includes application monitoring and logging and analytics for end user connections. It'll be clearer once we do the demo, how the integrated application delivery and analytics set of features that Avi provides. Let's talk about the use cases that we have deployed in. There are primarily three. First, a private and hybrid cloud, where we are a drop-in software-based elastic load balancer that's programmatic and has full cloud integration with OpenStack, as well as other cloud management platforms. Second use case that's common for our customers is a DevOps environment, where we are the self-service elastic multi-tenant load balancer, where the app developers can do a self-service provisioning of the VIPs. And finally, cloud service providers who are offering infrastructure as a service. We are an elastic L4 through L7 services solution with our consumption-based pricing model. It's perfectly suitable for these CSPs because they can pay as they go, as they bring on new customers. So what are these customers that I alluded to earlier? Well, we have primarily Fortune 500 to Fortune 1000 customers, from large enterprise cable companies to global financial services and e-commerce enterprises, as well as global cloud service providers. We also have some named customers, including Hitachi, among others that you see here, for which we have joint case studies available. All right, so with that brief overview of Avi, let's deep dive into the Avi's technology. How do we provide what we just said as an integrated application delivery and analytics? So what Avi has done is build the next generation of ADC, which is a software-based solution based on an SDN architecture for L4 through L7. At the heart of the solution is Avi Controller, which is a software-based controller, a control plane that is a repository and analytics engine, as well as single point of management and integration with APIC. It runs as a set of VMs, a cluster of VMs on your hosts. And also what it does is manages the full life cycle of the actual micro load balancers, what we call service engines. The service engines make up the distributed data plane. So when you configure a load balancing instance, the controller spins up this service engine. And as the traffic grows, it automatically scales these service engines into multiple instances, providing you that elastic service fabric. It grows as your traffic grows, as you add new applications or new tenants. These micro load balancers are placed intelligently so that you have full application affinity, and also provide the isolation for your application and your tenants. On top of the controller to REST API, what we have built is the Avi user interface, which is a single point of visibility and monitoring dashboard, as well as for configuration. It also provides a Google-like search interface for network traffic. You will see that in our demo. I should mention that REST API is a first-class citizen in our solution, which means everything that's available is through REST API. Our UI in our CLI uses REST API to talk to the controller. So that's very important for programmability and integration point of view. That brings us to the joint solution aspect of the solution. So we saw an overview of Cisco ACI with APIC, and we saw an overview of Avi. Now, how do these solutions map to each other, and how do they work together? So first, you can see on this slide is the similarity and the commonness of the architecture. Both Avi and Cisco are built on the SDN principles, where you have a centralized controller. For Cisco, it's managing the L2, L3 fabric and the service insertion, as Ranga mentioned. And for Avi, it's actually managing the lifecycle of these network services. And the network services are implemented in the form of a distributed data plane. In case of Cisco, it's the elastic distributed scale-out ACI fabric. In case of Avi, it's a software-based elastic L4 to L7 service fabric. Both Cisco and Avi provide open REST APIs for integration, as well as provide monitoring and analytics capabilities at the respective layers. So this similarity is what allows us to bring in the value proposition that the joint solution does. So you might ask then, okay, we have a good overview of both the solutions. How does the joint solution work? What is the value proposition, and what are some of the mechanics? So I'll spend a couple of minutes on this then before we move to the demo. So as I mentioned earlier, right, APIC is the central policy controller for the network fabric and for service insertion. Avi controller is a single point of management and integration with APIC. So whether you have one application or 10,000 applications, Avi is the last load balancer you'll ever buy because of the controller-based architecture. It integrates with APIC using REST APIs, and this has multiple benefits. First of all, because of the REST API, you're not limited to the small set of capabilities that typically a device package-based integration is. As a result, you can use the Avi UI for all the advanced capabilities and features in an APIC ACI environment. You don't have to create multiple device packages for advanced capabilities, for example. It's a single controller, single logical device to manage for all features, any scale. Second, with these centralized policy-driven controllers, both APIC and Avi, you have the data plane. So as the Cisco APIC programs the layer 2, layer 3 fabric and configures the policies for service insertion, Avi controller comes in and deploys these micro load balancers through its integration with vCenter on x86 hosts as VMs. What this allows to do is to scale this service fabric elastically as the traffic grows, right? You start with one or two or a few service engines, and then you can add them, the controller adds them as the traffic grows. Controller manages the full life cycle of these service engines. So from capacity management to automatic high availability to the traffic scale out to licensing management, intelligent placement, all of that is fully managed by the Avi controller. So what this does is this eliminates a couple of things. You don't need to deploy your active standby appliances anymore because the HA is built in. And you also don't have to over-provision your load balancers, for example, for peak traffic because the traffic grows, the solution scale goes as the traffic grows. And the final piece of the puzzle of the joint solution is the visibility and monitoring. So maybe Ranga, you can also talk about what type of network visibility at layer 2, layer 3, and the application layer that the APIC provides.
As we discussed, right, when an application configuration is deployed on the fabric, ACI actually has information about what endpoints belong to various different endpoint groups and what contracts are deployed between the various endpoint groups. So ACI can keep track of what communications are going on at a network layer between various layer 4 ports or between various layer 3 endpoints in terms of the traffic statistics, in terms of any congestions that might have been seen, in terms of any bottlenecks that might have been identified in the network. So the APIC, which is the controller in the environment, gathers all of this rich set of information from the ACI fabric and makes it available to the users through our dashboard. So we have quite a few a set of information that's available through our dashboard. We have this concept of a health score, which allows users to get a quick view of how the health of various different applications are and how the health of various different entities in the infrastructure are. We have a troubleshooting wizard that users could use, which will make use of the rich telemetry information that I talked about to identify and pinpoint network level problems pretty quickly. So all of this information is available through our GUI, but it's also available through our RESTful APIs for other tools like the Avi Networks technologies to essentially consume.
Yeah, that's an excellent point, because I think in this day and age, for example, what Avi does is provides and complements Cisco's network troubleshooting and analytics information with layer 4 through layer 7 services level visibility. For example, it provides log analytics at the application level, such as HTTP logs. It provides end user insights as to where the clients are coming from, what their latency experiences are, and so on. It does anomaly detection at the application traffic level. We'll see some of these in our demo. But as Ranga pointed out, with the REST API-based integration, you can combine and correlate this information to provide that full stack, full feature visibility from what's going at the application health level, and then track it down and say, this application issue is tied to either this server, to this network, to this end user's device. You can pinpoint and do root cause analysis of these application problems with this full L2 to L7 level visibility. All right, so I think we are one slide away from the demo. Before we do that, though, let's spend a minute on a joint customer that both APIC and Avi Solutions deployed in as a quick case study. So this is a Fortune 1000 enterprise in which the customer wanted to deploy layer 4 through layer 7 services for over 600 applications that the customers had. They wanted a multi-tenancy, full automation environment. They did have existing load balancers for the traditional environment. However, with their initiative of software-defined with Cisco, they wanted to be more agile. They wanted to be more programmable and software-defined. So some of the challenges that the customer shared with us were that they had, with the chassis-based solution, they had a very large failure domain. So they were looking for a software-based solution. Because otherwise they had to get an agreement from over 3,000 app developers before they could make any changes. There are a couple of other challenges in terms of how the hardware-based solution was integrated with Cisco APIC and the manual configuration required to set up individual devices. So what Avi provided was, we just saw the joint solution with Avi controller and distributed micro load balancers, single logical ADC with over 1,200 micro load balancers or service engines that are automatically managed by the controller. So controller has the policy, the service engines are managed by them in automated fashion. And because of the API, REST API-based integration within Cisco and Avi, all the features were available through Avi UI in the Cisco environment. All right. So as a result, what the customer received was a zero-touch provisioning, much faster application deployment, and over 65% on TCO savings. All right, so we're ready for the demo now. We are logged into the APIC environment, and let's go to the tenant. So in this case, what we have is an APIC setup with a tenant that we have created. On this tenant, we have this application profile. This is what Ranga had talked about, where you have a web application for which you have an application profile consisting of two EPGs, the client EPG and the server EPG. Let's look at these EPGs. On the server EPG, if I click on the server EPG, there are two servers, right? So these are the servers that we're going to be load balancing as part of the load balancing service insertion. On the client side, we have one client that we'll be using to generate traffic. Now let's go to the security policies and look at the contracts. And the contracts is where we have the policy that is set up that Ranga had talked about, which is how do these clients and server talk to each other. So in this case, the server EPG is the provider EPG, which means that's providing service via this contract to the client EPG. And if I look at the contract itself, as you can see here, there are some filters which have been set up, but there is no service graph, which means we have not inserted any service policy. We'll do that as part of the live demo. When we do that, let's also look at the L4 to L7 services. So what has happened so far is Avi's service graph template has been deployed, which means this is the template of the service chain that we will insert into that application profile that just we saw. This is the Avi's two-tier application profile. And the reason there are two tiers is because it allows us to scale out automatically. We'll see that in a demo as well. All right, so what we're going to do now is we're going to go here to this contract and attach the service graph, which the template, and press submit. So at this point, you will see that this service graph has been deployed right here. We just deployed that. What has happened is now APIC has done its part to insert the service graph in between the client and the server. What we do now is move over to Avi controller. So now this is the Avi UI. Now, the thing about the integration between APIC and Avi is that it's a REST API-based integration, which means we synchronize a bunch of parameters between the two solutions. We also synchronize the tenancy. So right now, I'm actually logged into the webinar tenant, which we saw was on the APIC side, right? So we are in the right tenant context. Then what we're going to do is go ahead and create a basic load balancing solution. It's a simple wizard now that will allow you to then put the actual service behind the service graph that we created in APIC. So here what I'm going to do is I'm going to select from a drop-down menu the service graph. Now this is very interesting. You don't have to manually configure anything in Avi. We have automatically synchronized the contract and the service graph that we inserted in APIC into Avi, right? So you click that, you'll give an IP address. It's 10.128.225.100, all right? So that's our VIP, or that's the load balancing IP address. Now what you're going to do is we're going to select all the servers in the server EPG. So instead of typing these pool servers manually, I'm going to select the server EPG from this drop-down menu, which will auto-populate the servers from that server EPG. If you wanted to configure HTTPS, this is where you can configure it and select the profile. For now, we're going to just select HTTP and just save. So at this point, what we're going to do is we're going to create this load balancing instance. At this point, we are spinning up a new service engine, which is the VM in vCenter. It's going to take a minute or two for APIC to pick that up from vCenter, put it in the right port group, and your the VIP will be available. So as you saw in the APIC side, all we did was connected the service graph to the contract, and on the Avi side, all we did was went through a quick wizard. It had all the endpoint groups imported. We picked those endpoint groups. We had the service graph imported, selected, and we are done. All right, so let's wait for a couple of minutes. Well, while we do that, what I'm going to show you is I'm going to log into another Avi controller and show you where we have some traffic running already so that I can show you the power of Avi UI while that whip comes up. So let me log into that controller. And all right, so in this case, I have a separate setup available where I have some traffic running and where I'm going to show you some other capabilities on this dashboard. So the first thing I wanted to show was, in addition to the automated deployment that we just did a demo for, we can also do automatic lifecycle management, including scale out. So I'm going to log into one of those virtual service instances or VIP. And what I see here is I'm running about 370, 380 megabits per second. Let me go to real time so I know what the traffic is. So it's about 380, 385 megabits per second. And if I see here, though, the application health score, as reported by Avi, has a resource penalty of negative 35. What does the resource penalty mean? What that means is, if I actually look at that, the resources that the Avi is using is running hot. In this case, the service engine or the micro load balancer is running at about 100% utilization. Now, this is for the demo purpose. That's why we are letting it even go here. In the real environment, based on the CPU utilization or other parameters, we would automatically scale out the Avi solution. So for the demo purpose, I'm actually going to do a manual scale out. Let me go back to the analytics dashboard, look at the throughput, and what I'm going to do is I'm going to go to this VIP. As you can see here, it is served by one service engine or one VM. I'm going to click on scale out. And as I said, in a normal environment, this would be automated based on parameters. What this is doing is actually talking to vCenter, spinning up a new VM, or if it's an existing VM, reutilizing that, plumbing into the right network with APIC's case or through APIC, and then now you have two VMs serving a single VIP. And while we were doing that, the traffic has automatically shot up from 380 Mbps to over 550, and it'll go up to about 600 something Mbps. What this shows is that unlike legacy hardware-based load balancing environments, with this elastic load balancing solution, you can scale out and scale in on demand based on traffic, based on resource utilization. And really, you don't have to provision on a peak capacity basis. You can grow as your traffic grows. This really simplifies your operational model at any scale when you're deploying your solution at any scale. Okay. So this is, again, very powerful, and this is fully integrated with APIC. So in this case, what it would do is talk to APIC, install and configure the new logical devices, and go from there. The last part of the demo that we want to show before we look at the question and answers is some of the visibility and analytics capabilities. So let me go to one of the virtual service instance. Let me select actually 6 hours. So you might have noticed this end-to-end timing dashboard that we have at the top. What does that mean? So let me walk you through that. What this says is that over the last 6 hours, the average latency from your end clients to the Avi load balancer, which is typically in the data center, it's about 100 milliseconds. The latency of your local data center network from Avi to the backend pool server, so this is where it's load balancing, it's about a millisecond. The application is taking over 120 milliseconds to process the request, and the data transfer time is about half a millisecond, with a total RTT of just about 223 milliseconds. This is something unique to what Avi does. There are no agents anywhere. There are no span ports, no monitoring fabrics. This is full inline analytics driven visibility where we can tell you end-to-end latency breakdown. This is very powerful. For example, as a network admin, you probably know that you get blamed for every performance issue in your environment. And many of our customers like to call this mean time to innocence tool. Why? Because it shows that my local data center network is not a problem. If there is anything I want to optimize on, it might be the application response time, or maybe look at the WAN RTT. Right? So this summary view end-to-end timing dashboard is very effective for high-level visibility and troubleshooting. But that's not it. I can also do needle in the haystack-like analytics where I can do a Google-like search on my traffic. So for example, in this case, I'm seeing all the HTTP and TCP logs in front of your screen. And I can say, okay, show me only iPhone traffic. So if I just search here and say iPhone and click enter, it'll show me all the iPhone transactions. So for example, if I open one of these up, I can see that this transaction is coming from India with somebody running Safari on an iOS iPhone. Took over 700 milliseconds to hit the load balancer. It was looking for a home page URL, and the application took about 300 milliseconds to respond. The total latency was a second and a half. It's slightly on the high end. You can also say, show me all transactions which are coming from iPhone from client location equal to China. So I can say who's from China coming in. And in that case, again, if I were to open one of them up, you can say that this person is coming from China. So very powerful log analytics available for any kind of troubleshooting. I'll give you a quick example. So let's say you're a network admin and says you get a call saying, over the last couple of hours, I'm seeing an increased latency, and say, okay, let me troubleshoot that with this dashboard. First thing you would do is click on the end-to-end timing dashboard. Now let me actually go to the past 1 hour because the complaint's coming in for the last couple of hours. So let's see what's going on. So if I click on the end-to-end timing dashboard tab here, I'll see the histogram of all the latency spreads, end-to-end latency spreads. So you can see that majority, of these transactions, about 90% of them are taking less than 400 millisecond. However, about 9 to 10% are taking over 400 millisecond. So let's analyze just those to see what's going on. If I click on that, automatically my query gets populated with that search, which says 400 to 800 milliseconds. And now I can see, let's see which one of them and see what's going on. And in this case, almost all of the latency is on the client RTT side. And this guy's coming from India on a Firefox. Let's open up another one and see if we can spot anything. In this case, also coming from India, but in this case coming on a Chrome browser from a Mac. So to further analyze this, what I can say is, let's see what my location analytics tells me. So while I'm searching for the 400 to 800 millisecond latency, I click on the location bar here, and that shows me that almost all, or at least 70% of my high latency queries are coming from India. So that tells me that potentially there is something going on the WAN side of my Indian office or Indian data center, which is taking such a long time, whether it's a set of users from India or the WAN link that's creating this extra latency. So from this, I can actually go down to my network team and say, let's look at the WAN link for the Indian office. This is very powerful from analytics point of view. All right, so that brings us to the end of this part of the demo. Let's go back to our Avi controller and refresh the APIC service engine, the VIP that we had created. And right here, our VIP is ready here. In this case, we're running some traffic. So let me go to real time. And so this is the VIP that we created from APIC. So we ran some traffic. We look at the client logs. So let's look at the client logs and see, look at non-significant logs as well. And maybe over the past hour. And we should be able to see those traffic here, right here. So in this case, we generated some internal traffic and looked for index.html on our web server. Similarly, if I go to APIC, you can actually see that this has been deployed. So this is the device which have been deployed. So right here, that the Avi service engine, which is the load balancer, has been deployed in the right network automatically by APIC. And that's providing you this load balancing service. All right, so that brings us to the end of the demo part. Let me take questions, and I'll also summarize the webinar. First question that I see here is, where is SSL handle? This particular virtual service, we have SSL configured here. And with SSL, we can do both both ECC and RSA. So in a single VIP, we're able to handle both the elliptical cryptography or forward secrecy, as well as RSA. And so depending on the clients, you can handle both type of certificates. Okay. More question. How do you compete against some of the from the other load balancing solution. So I think the main difference that Avi has is a software-based elastic solution. It's been designed for the next generation architecture. So it's fully scale out. It's full feature ADC. So what you expect from existing vendors is a full feature ADC, but in a more software defined elastic form factor. Let's see if there's a third question here. Yes, we handle SSL. So the question is, do we handle SSL for large keys? The answer is yes, 2K, absolutely. Performance is not an issue. What Intel has done actually is done a fantastic job of building the next generation processors. So performance is never an issue. Plus with our architecture that scales out automatically, we can add new micro load balancers and stretch a single whip across multiple of those. So we scale linearly. Ranga, let's summarize this demo. So I think what we saw was that with the similar SDN architecture between Cisco and Avi, we have solved the application deployment challenges, which is how fast can you deploy application, how fast you can deploy the solution, how you can provision the network services and provide full visibility.
That's correct, Ashish. So I think the fact that both the Avi controller and the Cisco ACI infrastructure are both application centric at different layers. Avi controller being a layer 4 to 7 infrastructure management solution, and the Cisco ACI being a layer 2 to 4 solution. They are extremely complementary, and the fact that they are application centric makes it very easy to not just deploy but also troubleshoot and manage application configurations.
Excellent. And so for more information, you can go down to cisco.com/go/ACI, as well as you can go to avinetworks.com and go to there's a link to the Cisco solutions. You can also start your free trial on our website, where you can download the software in your environment and play with it, as well as reach out to us if you have any questions or want to see the demo in your environment. So if you have any more questions, you can reach out to us. My email is ashish@avinetworks.com. Ranga's is rangrao@cisco.com. We'll be happy to address more questions. So thank you for joining the webinar today.